Next I'll talk to you about Flutter, which is a new mobile framework for creating mobile apps. Our main goal is to really help developers. So I hope there are a lot of developers in the audience tonight that are interested in hearing about this new framework. There are three ways that we try and help. We try to help you to create your apps faster. We understand that there's a lot of time pressure involved when you're creating apps, whether for yourself or for clients. We help you get a consistent experience across a multitude of devices and operating systems. And lastly, we help you with really creating expressive designs that may have any custom look and feel that you desire. And we will look at all three of these points in details. And I will do some talking, and I will do some demos as well to really try and show you this product. First of all, let's start with productivity and how we can make you develop faster. The first part here is our very design-oriented development workflow, where we use a very declarative style to creating UI, something we call UI as code. I want you to try and look at this screenshot here and think about what's actually on the screen. Especially for the screen in a very structural fashion, what do you actually see on the screen? One way to think about it is that there's a column that encapsulates the whole page, and this column has some elements inside it. The first element is an image. The second element is a row, and inside that row we have a couple of pieces of text, a start shape, and a number. The third element is another row that has three elements inside it. And then lastly, there's a fourth element, which is a large piece of text. So the way you would describe this UI in Flutter is, as I mentioned, using code. So this is the program for this piece of UI, or at least the start of it. You can see in the code we declare a column, because as I mentioned, this is a column, and there are 4 children inside this column. There's an image section, and I'm passing in a configuration value to tell it what the image path is. There's a title section with some more configuration values, a button section, and a text section. So that corresponds to that column we saw before and the main 4 elements. So that's the high-level structure of this page. But of course, there are more details to look at here. So here's some more detailed code I want you to try and take a look at, and try and reason about in your heads, what do you think this will produce on the screen? We have a text part we're declaring first that has a column. There's a row with some children on it. You may have guessed this, but this produces that second element on the screen. You can see there's the text part, that's just a column to get those 2 pieces of text on the left to actually align. And then there's an icon. We're selecting a shape based on predefined material icons. We're setting a color to make it red. And then lastly, we're just reading out the current value of stars and printing that as a string. So again, hopefully, this is very easy to read. And there's not some fancy templating language or anything like that you have to go learn. You just have to learn to read code. And because this is code, it also means that there are other skills you don't have to relearn, such as how do you repeat things. There's a lot of repetition in this part of the screen. There are 3 actions that do the exact same thing. They have an icon with a piece of text below it. And you wouldn't want to just repeat this out. You would want to reuse some of this repeatedness. Again, because we're using UI as code, you can do this in the way you're used to. For example, we can encapsulate this in a class. So we've declared a custom class called icon action. And what you're seeing here is a row, because this is a horizontal layout, and then 3 calls to the constructor, and we're just passing in the configuration values again. So 3 icons, call, near me, and share, that correspond to the 3 shapes, and then the 3 strings below them. And if you're wondering what that class looks like, this is the full definition of that class. So again, it's really, really simple. The build method is where we actually render to the screen. We're reusing something called Inkwell from the framework, which is able to detect pushes on the screen. And it's called Inkwell because when you push things on mobile, you often get this animation of like ink running on the screen, just to tell you that you've pushed something. Then we have a column, and inside the column we have only two things, an icon and a container. And we use the container to encapsulate, or sort of to enclose the text to be able to add some padding to it. So you can see it's a very hierarchical layout, and this may seem different or strange at first, but I can guarantee you that once you kind of get used to the thinking, it becomes second nature. And you really just have to think about it as code. So in summary, it's a very design-oriented approach. Actually, at Google, when we work with designers, we sometimes just sit around and actually look at these programs together, and we found that even designers with some technical aptitude can actually read these programs. Everything is a widget. So you saw before, icon action was a custom widget we declared. If you reuse some other widgets, some of those were things like text, but other were things like inkwell and column that are more behavioral. So a widget is not only a control, it can also be behavioral, like add padding to something, or censor something, or put things in a row. We call all these things for widgets. And there's a single language for all of this code. And for those in the room that have used some of our other offerings in the past, we're using the Dart programming language, so that should seem very familiar to you if you know Dart. And if you don't, it's a very traditional class-based language that we find most developers who know either Java or C# or Swift can learn very, very quickly. Okay, so we have code now, and I'm betting some of you are thinking right now, there has to be some WYSIWYG designer. How are you going to ever create this just from code? It's too abstract. There currently is not a WYSIWYG abstraction designer, but there is something else that I will demo to you that you can use in a similar fashion. But first of all, before we get there, we've taken a very, very flexible approach to tooling. You can do a lot of things from the terminal if you want. You're seeing 3 commands on the left: creating an app, looking at any attached devices that we can run on, and then actually running the app, including building the app. So you can do all that from a terminal and use your favorite existing editor. Or you can use some of our integrated editors. At the top you're seeing IntelliJ IDEA, where we support the free community edition. You can also use Android Studio as a variant of that. And we also have some community members that build support. So at the bottom you're seeing Visual Studio Code that you can also use if you prefer that. But back to this hero feature that I talked about called Hot Reload. And I won't actually show you this image, I'll give you a demo instead. Okay, so now you should see Android Studio with some code, and you should see an Android emulator. Can I get a hands up from someone if you can see that? Perfect, thank you. So we're looking at this app, and we're trying to figure out why it's not doing the right thing. And it's missing those buttons at the middle. And this is a little bit of a trivial example. You can see that the other developer has added a note that there's some bad alignment, and he's uncommented the comments in this section. I'm going to remove the comments. And then I want to hit save now, and then look at the emulator and see what happens. So here, in a few hundred milliseconds, we were able to apply this code change and re-render the whole screen and show you the visual effect. So you should have seen those buttons reappear over here. The buttons are in the wrong location though, so we need to fix them. So I'm going to go to declaration and go here, and we will see there's an alignment property, and they're centered to the end. So I'm going to fix that, and let's try to center them. I'm saving again, and you're seeing the effect of that save immediately. That still doesn't look right. So I'm going to try, let's try and space them evenly and save again, and you're seeing the effect. So in many ways you can use this like you would have used a visual editor, only it's not limited to just those operations supported by the editor. You can make any code change here. So let's continue a bit. This is not supposed to be yellow, it's supposed to be red. It's a little too dark, we'll make it lighter. I don't like the padding here, so I'm going to change the padding here. So we're getting close now. At the top there's a little heart logo, and currently we have 42 stars, and I clicked it. I'm going to unclick it, and you will notice a bug if you can read it. It's still at 42. I click it again, it goes to 43, and I unclick it, it's still at 43. It should decrease when I remove my heart. So that's a bug somewhere. So let's go back to the top. We'll find the app bar. We'll see here that when you press the heart, there's an event handler here called onPress. We'll go to that definition, and you'll see this is the code for that event handler. And there's some trivial logic in here. It looks like this line is misplaced. We're adding one outside the conditional. So we'll just move this up and save again. And I do this to demonstrate that I can do any kind of change, not just visual changes. So now the behavior of the button should be correct. You can see it increasing and decreasing as I click it. Okay, so we talked about our developer experience and how we have a really unique framework using UI as code, and I demonstrated hot reloads. Wondering what kinds of apps can I actually build with this? First of all, I mentioned everything is a widget, and we have a large selection of widgets. We have just about any widget in the material spec for Android. We actually work really closely with the material team and have a, I think, really precise implementation of all those widgets. We also have a good selection of what we call Cupertino widgets, which are widgets with an iOS look and feel. And the important thing is, these are actually all in our framework. We're not relying on any other widgets that may exist on the platform. We are rendering everything on the screen, which means you get a really predictable layout, because we include the source code for these widgets directly into your application. So when you deploy your app, it's carrying around its own definition of all these widgets. That may also sound a little bit scary, and you may be worrying now about performance. We spent a lot of time on this problem. At the bottom, we have a super performant engine written in C++. We've reused years of investments here, so we're using Skia to do graphics rendering based on learnings from Android. We're using text rendering based on learnings from Chrome. And we're using Dart that we've built for the past more than half a decade. So that's all in C++. Everything in green is written in Dart. Everything in green. That means anytime you see an animation, anytime you scroll, anytime you click a button, you're in interaction with Dart. That's great if you're a developer, because you can go and look at the definition of all those levels of the framework. It's also great if you want to customize. Let's say you want a custom gesture, or a custom animation, or a custom widget. You can go and read our implementations and create your own based on ours, or you can even tweak our definitions if that's what you like. And you don't have to worry about all these green boxes being slow. We spent a long time on this. When you run in that development build before, when I was showing you hot reloads, you run in a virtual machine. That's the only way you can get such a fast refresh cycle. But then when you do a release build, and you build an APK for uploading into the store, or an IPA for iOS, we do a full compilation to native machine code. So you're actually running machine code by then. You get really fast startup, and you get really fast execution speed. So that was a massive investment. We also spend a lot of time actually tuning our runtime to work great for UIs. Imagine doing an animation at 60 frames a second. There are a lot of objects being created to control those. So we build lot-free fast allocation to make sure we can keep up. And then as the animation passes, there's a lot of objects not being used anymore that you need to go garbage collect. So we use something called generational garbage collection that's really optimized at collecting young objects that have only been around for a short while everything else that sort of app stays in an older space. So those are some of the ways we get really great execution speed. And I really mean it when I say our goal is to run it at least 60 frames a second for any app you may write. So the end result is you can run your apps on Android, you can run your apps on iOS, you can run them on both. You can create a single UI that's consistent across both, or you can use those different sets of widgets and redo something that's unique. We also help you, because we know that customers really care about consistency. You may not catch it in these animations, but if you look at the way it overscrolls, for example, you'll see that on iOS, you get this bounce behavior when you scroll too far, but on Android, you get the blue glow. You may also notice here in the upper left-hand corner that the back arrow is different. So we use the correct symbol for the back action. So we've obsessed about these little details to make sure that it really looks the way customers expected it to look. And we've even done A and B studies here. Customers are just not able to tell the difference between this and something written with the native platforms. Okay, so that was the second part. Now the apps run really, really fast and they look consistent. But when we talk to customers, we hear about a new trend that's starting. There are a lot of customers that are really interested in creating something special, creating something unique that really makes their brand come forward, something custom. I have 4 examples here. On the left, you're seeing a custom navigation style that uses these 4 sections with some smooth animations. You're not seeing the full frame rate here over the video call, but if you run this, this is called the Gallery app, and you can find this in the Android store. And you can install it and try it yourself. It runs really, really smooth when you try it on your phone. The second thing is a concept for a sports application. You can see they've customized everything. The fonts are custom, the buttons are custom. It really is a brand-specific design that was crafted just for this purpose. In the middle, you're seeing Google. That's one of our early customers that are presenting this week at the Slush conference in Helsinki. They've created this custom animation that really is the hero of their homepage. And if you look at the bottom, you can see they customized the button navigation to have a 5th element, which is this magic wand. That's another example of taking our widgets and just customizing them and layering our behavior on top. And then lastly, on the far right, you're seeing work from our community. There's a blog you can go read here at Sergi and Replace if you want to learn about how he built this app. It's a great example of step-by-step building out something custom. But again, I wanted to demo this to you just to show you how to do this in practice, because it may seem a little overwhelming in these animated GIFs. So this is a real example from a few weeks ago where I was working with a customer, and he wanted this circular button that says "Click Me" on the slide. And he told me he wanted a fixed size, he wanted a light gray background and a blue border with text in the middle, and you should be able to tap anywhere in the circle to get click events. And my first inclination was it sounds a little bit like the floating action button on Android, but he said, no, it's not floating, and it can be anywhere in the page. It shouldn't always be in the corner. So what I will show you now is how to actually build this widget from scratch. Okay, you should now see IntelliJ, and you should see an iOS simulator. Can I get a hands up again if you can see that? Great, thank you. Okay, so I've just stopped out the app here, and you can see I've created a new class called Circular Button. We will go to declaration, and this is just an empty class almost. It has a constructor for passing in the thing in the middle of the button, and it has an event handler we're passing in. And then the build method right now does nothing but just return the past child in a centered way. So that's what you're seeing here. It doesn't do anything, I can't click it. And I mentioned, it's a little bit like the floating action button, but I also said earlier, in Flutter, everything is source code. So let's just go look at the source code. So if I go back here, here's the floating action button, and we will go to declaration. And you'll see this is the constructor of floating action button. Let's scroll down a bit and find the build method, which is where it's rendering, it's here. And we will just borrow the source code here. I'm just going to copy this and put it into my own button. We need to make sure we put the contents inside it, and we need to make sure we return the result, and we need to make this a variable. You see all these squiggly lines? Those are things I have to fix now because it's not entirely working in this context. So the color, I will just make this gray. There's some elevation property. We don't want the button elevated, we want it flat, so I'll just remove this line. And then there's width and height. The customer wanted these to be fixed, so I will make them fixed. And then this is the untap handler. Let me just fix that name. And we don't want the highlight. And now the code passes analysis, so I can apply the hard reload. Okay, well, we got closer at least. We have a round circle now that's gray, and you can see I can click it. So that's closer. It's not entirely there, right? Because we need that blue ring around it as well. So let's take a look at container and see what you can do with containers. And it looks like containers have something called decoration. That sounds promising. Decoration here. New decoration. I need a box decoration. Okay, let's look at the box decoration. It has a border and a color. Okay. I'm going to make this blue. Okay, that's not entirely the result either. Now the whole circle is blue. We just want the border to be blue. Let's just look again. I think on these decorations there is a border. Let's try and set the border. Okay, we seem to be getting some border now, but it doesn't look like a circle. So let's just go back and look again. And it looks like there's a shape property. Oh, the shape is defaulted to rectangle. That doesn't sound right for our purpose. Shape, let's see what other options we have. We have circle, okay. Okay, and now we just need to get the color right. I think all we need to do, right now we're applying the blue to the whole box. So we want to apply blue just to the border. And there we go, we have our circular button. So of course, I mean this, you can see that I've done this before. When I did this a few weeks ago, it took me a little bit longer than right now. It probably took me realistically about half an hour. But I think it's fair to say that the ability to go and read the source code of all our widgets and use them as a starting point, combined with this ability to step by step just add a line of code and apply it and see the effect of it is a really powerful technique. And that's that same technique that our customers use to create those much more complicated examples that I was showing you before. And I hope you find that, that appealing. Okay, so let's do a little summary. I want you to understand that Flutter is actually really different from many other frameworks you may have heard of. This is one of the ways in which we're very, very different. I've shown you our widgets being all source code and being compiled into the apps. We call this approach framework widgets. This is different from any other framework I know of, at least the mainstream ones. There are lots of frameworks that use what they call native widgets. So those are widgets that are almost compiled into the operating system. That gives you a few advantages, but also quite a few disadvantages. And then there's a second approach where you try and use a web view to render things, which we found is not the best way to do it for performance. But again, any of these approaches has pros and cons, and I'm not telling you that Flutter is perfect. It certainly has pros and cons, but we do think it's at least quite unique and something we invite you to take a look at. The second dimension in which we're quite different is actually two dimensions here. On the left side is the approach by which you construct your views. Traditional SDKs and things like Corolla and PhoneGap, it's sort of a model view controller. I didn't show you this in the app, but maybe you recall when I was fixing the heart that nowhere was I really like telling the UI to refresh. I was just changing my state. That's called a reactive style. So all I did was I muted the state of my view, and then the view knew to go recompute itself and re-render to the screen. Flutter uses reactive views in a very similar fashion to React Native, but as you can see on the other dimension, the main difference there between Flutter and React Native is that we compile everything to native machine code, where React Native relies on interpreting JavaScript and doing a lot of hops between JavaScript and native code at runtime. So we think we have some performance benefits there by being all machine code. And the full combination of this, when you add everything together, we believe, is a much faster way of developing apps. You can write everything as code, you can use coding techniques, and you can single source your app for two different operating systems and a wealth of devices without having to worry about things like compatibility libraries and similar things. We give you a consistent rendering across all devices by carrying our own dependencies. We have great support for widgets for both material design and Cupertino design. And then lastly, we think quite uniquely, we have a great framework if you want to create some of these more custom designs and really make your brand come forward. If you'd like more information, here's some details. Our main homepage is flutter.io, where you'll find tons of information. Flutter is entirely open source. So if you go to github.com/flutter, you will find all our repos. Everything is up there. We have nothing internally. It's all open source. You'll find our issue trackers. You will find our plans. You will find everything. If you want to go read about Flutter, there's a number of articles in Medium, some written by us and some written by the community. They're all tagged with Flutter. If you try Flutter, you can log issues in GitHub. You can go and post new questions or read existing ones on Stack Overflow. And if you really want to engage and talk to others in the Flutter community, there's an online chat forum called Gitter, where you can hang out and talk to others. All right, that's it. Let's open it up for questions. I think you're muted on the
Thanks, Michael. Вопросы? Если что, мы можем перевести.
Можно по-русски, если есть.
So any questions?
Релиз когда? Релиз. По-русски.
Давай. Ты профессиональный переводчик.
When's the release?
We released already. We released a build roughly every hour, right? But I guess you're asking me when will we go into a stable release? We are currently in alpha. We've been in alpha since we announced that at I/O earlier this year. It's important for me to note that it's not alpha in the sense that this is this scary, unstable thing you should run away from. It's alpha in the sense that there are a few missing features we're still trying to add, but all the features that are already there are very, very stable. We have a number of customers using us already in production. The biggest customer is an American company that did an app for the musical Hamilton. It has more than 200,000 installs, and we want to take very good care of them and other customers. So everything that's in the framework is actually quite stable today. I can't tell you when we will go to beta, but I would be very disappointed if it didn't happen next year.
Okay, another questions?